Assalamualaikum warahmatullahi wabarakatuh to both of my panels, which are panel 1, Cik Zubir, and panel 2, Cik Zulkifli. My name is Ahmad Rifdi Amin Khalili bin Muhammad Nasri. I am from Faculty of Electrical and Electronic Engineering Technology. Today, I would like to present my bachelor degree project entitled Apps-Based Sec and Transient Identification for Power Quality Monitoring under supervision of TS Ahmad bin Abdul Rahman, and my co-supervision is TS Yahar Akbar bin Muhammad Abdul Ghani. As for the introduction, in an electrical power system, power quality monitoring is an important service offered to the industrial and the main commercial customers by electrical utilities companies. The power quality disturbance cause enormous financial losses to electricity companies, the customers, and electrical suppliers, especially for the industrial customers. So in this project, a new power quality disturbance analysis and identification software tool has been developed to build an app-based monitoring system. The software is created using the Wavelet Transform MATLAB software with graphical user interface, which is GUI, and the Arduino Uno. To achieve the goal of this project, three main objectives are being carried out, which are the first one is to design and simulate the model of voltage surge and voltage transient disturbance using MATLAB and Simulink. The second one is to create an app-based monitoring system built in software tool that can monitor type of faults and disturbance by using coded algorithms in MATLAB software environment with its own graphical user interface, which is GUI, and the Arduino Uno. And for the last one is to run the functionality and perform analysis of the complete app. As for the methodology part, the flowchart of the project development is created to ensure the flow of the project to be accomplished. In order to plan a good secretary, background research needs to be facilitated into this project, which is the literature review. This project is sorted into two sections, which are the development of the hardware and the software. The app is structured into a form of a circuit within the hardware part. The circuit includes the microcontroller and the Wi-Fi module as the fundamental part. As the control circuit, the PC that is interfaced with the microcontroller and the Wi-Fi module structure will be related. The programming code for this project is created in the software development part by using the software considered. Three types of programming software, which are the MATLAB, Arduino, and the Blink app will be used in this case. The MATLAB software will create the necessary waveforms and the voltage sag and voltage transient magnitude to program the information motion. The Arduino software is applied to program the microcontroller for the app system, while the Blink app is connected for observation and interfacing purpose to control the entire framework. Before running the full program, the project flowchart should be planned in this part of the software development. Finally, through the implementation of the Arduino integrated development environment, which is IDE software, the entire programming can be troubleshooted. Once the hardware and the development are established, the project operating framework will be progressively tested. So in this case, if the project is not functioning well, the programming code must be further reviewed and edited, composing and troubleshooting of the project's circuit accordingly. So lastly, the consideration may be given to improve the app for the power quality system. So in this methodology part, also show the general idea of the app system framework. Uh, the The procedure structure and build up the app is as a device for screening and transmitting data to a focal control unit, a review in the literature review. When the app can distinguish what type of distortion and fault occur, the framework will transmit the information directly in real time to the focal unit. In this case, after a certain amount of the time, the app kept the voltage drop disturbance away from occurring. The administrator placed in the control room can make a quick decision to take action to alert the TNB authority to go to this region to deal with the app issue and take care of them. As for the software development part, there are three types of software application which are the MATLAB, Simulink, the Arduino and the Blink app used to develop this project. For this project, there are three stages to construct the program, which are input for the MATLAB software, the system which is the Arduino used to run the MATLAB coding and algorithm, and the last one is the output which is the Blink app. Uh, in stage input in input stage, project input will be transmitted and calculated to create the normal voltage signal. This reading will clarify the fault signals for voltage sag and voltage transient by using the MATLAB Simulink program. In the system stage, the Arduino Wemos is used in the app framework to create the microcontroller program. Finally, the constructed GUI is used in stage for the output for communicating with the Blink app to observe the interface of the entire app framework for this project. As for result and analysis, the input of the project is obtained from the drawing block in the Simulink MATLAB to represent the voltage sag and voltage transient simulation. The fault resistance and the RCL load is set in the simulation to produce the sag and transient fault output waveform. The output waveform is analyzed using wavelet transform method to determine the time interval of the fault occurrence. So for the overall of the app system, the microcontroller will be ready to receive the signal when the app system is switched on and the incoming fault event from the MATLAB simulation is measured. If voltage sag or voltage transient disturbance occurs at substation A or substation B, the fault data will be displayed in the LCD in the Blink app. So as I point, this is the Blink interface which notify the users when the incoming fault occur. The next data will be sent to the Wi-Fi module and a notification will appear on the Blink app to notify the relevant party or staff of the problem of the disturbance at substation A or substation B, like I said earlier for this Blink interface. So in this case, voltage sag or voltage tension are likely to be occurred. An individual in charge, such as the TNB staff, will be given the specific of the disturbance and take steps to resolve the event of the fault. So the app device can be reset by pressing the reset button after the problem has been fixed, and the app can resume working in order to detect the next fault event. So as the fault this detection, the app needs to be tested and checked to ensure the reliability of the problem. The whole project after design of the app system circuit is finished. The power supply from the PC is used in the testing process to turn the app system on and initiate the Wi-Fi module. So the MATLAB Simulink sensor features is then generated to be and will be sent to the app, so it is possible to test the observed fault. The app is used at substation A and substation B, which is situated next to the main supply to detect any disturbance that happened. If the voltage at substation A tends to detect a sag fault, it will show the sag status on the side. Otherwise, if the voltage at substation B tends to detect a transient fault, it will show the transient fault. It will show the transient status. at the site. So as I pointed, this is a MATLAB GUI. GUI is used to examine the type of fault occur at the substation. If either of the set disturbance occurs at substation A or voltage tension disturbance occur at substation B, the red LED will be switched on and the fault data will be presented on the LCD installed in the Bing app. So the users can further examine the disturbance by uh, entering this GUI, MATLAB GUI that being coded with the algorithm. So for the analysis using the optimal method, this analysis aims the best method to detect the accurate initial and the endpoint of the voltage sag and initial point for a voltage tension. So as we know that the voltage sag is the reduction of voltage in the range setting in 0.1 pu to 0.9 pu, while voltage tension is a temporary unwanted voltage range from a few volts to several thousand of volts. So the wavelet transform method is used to localize the disturbance in time frequency. So as I pointed as this image, this is represented as a seg output waveform. So to analyze the time interval and duration of the disturbance occur at substation B and A and substation B, the output waveform is analyzed by using the first and the second derivation of wavelet transform to obtain the accurate result with less error when the simulation is run. So by pointing this is the first derivative method of the wavelet transform, and this one is the second derivative method for the wavelet transform for voltage sag analysis. So for voltage sag analysis, the simulation uh, of the sag port is initially set at 0.1167 seconds and end at 0.7167 seconds. So the switching of the duration takes about 0.9 seconds of the fault occurrence. Uh, as for the transient waveform, which I pointed at this image, the simulation of the transient fault is set at 0.0231 seconds with no endpoint because transient fault is only triggered at one time in a very short duration from under 50 nanoseconds to 50 milliseconds. So like the same as the sec simulation, this one represent the uh, first derivative of wavelet transform method, and this one is the second derivative of the wavelet transform method. As the result of the output, the table shows the comparison of the output waveform analyzed from the first and the second derivative of the wavelet method. As for sec fault simulation, the switching time is initially set at 0.1167 seconds and then at 0.7167 seconds for the duration of 1 second of simulation. So the duration of the sec fault occurred in the duration of the sec fault occurred is 0.6 seconds. By the first and second derivative of a transform, the time calculation of the output waveform can be obtained with the most accurate value with the less error based on the time recorded in the simulation. The suggestion of method is based on the time calculation with less error. So in the first derivative method of the voltage sag simulation, there is no error for the starting time compared to the second derivative method. And for the endpoint, the error from the first derivative method is higher than the second derivative method, which means the ending point that has been analyzed using the second derivative method is much accurate to the time recorded after the simulation is carried out, which is 0.1167 seconds. Uh, so the duration of the fault occurrence is likely as the same as the actual result in the simulation, which is 0.6 seconds. Hence, the first derivative method is suggestively chosen to analyze the sag output waveform. for the less error compared to the initial and end value that have been set in the simulation. So as the sec transition fault simulation, the switching time in the simulation is initially set at 0.0231 second for the duration of 0.1 second of time of the sequence occurrence. The output waveform is only strikes at one point, which is only occurred in very short duration based on the voltage transition disturbance. The first derivative of the wavelet transform of the transition fault analysis is detected at 0.0234 seconds, which produces more error than the second derivative method, which you can see in the table. The second derivative method detect the fault at 0.0232 seconds, which means more accurate to the actual switching time after the simulation is run. Thus, the transition fault analysis for the transition fault analysis, the second derivative method is suggested chosen to analyze the transition output waveform for the less error compared to the initial value that have been set in the simulation. As a conclusion, the framework of this app system consists of a circuit board that acts as an interface between the hardware system of the project and the GUI system that have been implemented as a software and monitoring system. As one of the wireless protocol implemented, the app hardware and software system is also integrated with the use of the Wi-Fi module. Nevertheless, the Wi-Fi module has a limited range of up to 35 km. In this case, long-distance connection is commercially supported, so it works better to be used significantly in the app. It is compatible with the purpose of the app for the detection and monitoring of any interrupted signal at the substation, thus sending its data directly to the control unit within the network range. So that's all for me. Thank you.